In 1959, the American Locomotive Company walked into a storm of doubt, industry pressure, and fierce competitors who expected another failed experiment. Instead, Alco unveiled the 251 engine, a power plant that turned every skeptic silent within a single test run. The engine delivered cleaner combustion, higher thermal efficiency, and a reliability curve that forced engineers across the nation to reevaluate everything they thought they understood about medium-speed diesels. Rail insiders whispered that Alco had crossed a line, raising questions about how a company under such intense scrutiny could suddenly produce an engine with such advanced metallurgy, improved turbocharging dynamics, and remarkable fuel performance. Some claimed Alco stumbled onto something ahead of its time. Others believed the company intentionally held back its real capabilities until the moment critics gathered to watch. What happened next reshaped diesel engineering standards, disrupted competitive alliances, and pushed the Alco 251 into the center of one of the most heated debates in locomotive history. The late 1950s created one of the most intense competitive environments the American locomotive industry had ever seen. Railroads were transitioning fully into dieselization, and companies fought aggressively for market share. General Motors' electromotive division held a commanding position, supported by extraordinary brand influence, extensive service networks, and engines with a track record that railroad executives considered dependable benchmarks. The EMD 567 engine already circulated through major Class I railroads, shaping expectations about what a diesel prime mover should deliver. Inside this environment, Alco operated under a microscope. Analysts dissected every announcement from Alco's Schenectady facilities, examining production figures, order books, and mechanical changes with heightened scrutiny. Engineering journals published direct comparisons between Alco's earlier 244 engine and EMD's 567, framing the competition as a clash of two philosophies, one focused on bold technical refinement, the other rooted in consistent field performance backed by a dominant corporate network. Railroads monitored Alco closely because the company represented something that unsettled the established order. Alco maintained a long history of locomotive innovation, and many insiders believed the firm possessed engineering capabilities that could disrupt the comfortable hierarchy surrounding EMD. Competitors watched Alco's every move, anticipating either a breakthrough or a miscalculation that could shift the balance of power. Within the industry, discussions grew increasingly intense. Some mechanical officers speculated that Alco's engineers were working on a project that could challenge market assumptions. Others insisted that the company faced internal barriers that limited its ability to compete at full strength. Trade publications hinted at boardroom debates, strategic disagreements, and pressure from investors who wanted Alco to deliver a diesel engine capable of reshaping locomotive standards. The climate created an atmosphere filled with predictions, rumors, and behind-the-scenes conversations. Executives, engineers, and technical analysts all understood that the next Alco engine would either elevate the company or fuel ongoing skepticism. Every technical bulletin, every prototype sighting, every testing rumor triggered industry-wide discussions. Alco stood on the edge of a defining moment. The arrival of their next engine would determine whether the company would reclaim influence or intensify the controversies already surrounding its future. When the Alco 251 appeared in 1959, the reaction across the locomotive industry resembled a shockwave. The engine entered a market dominated by predictable trends, yet its design signaled a dramatic shift in engineering ambition. Specialists who examined early technical reports immediately focused on the turbo supercharging system, which delivered consistent boost pressure across a broad operational range. This created combustion stability and power curves that attracted immediate attention from mechanical departments seeking stronger performance at sustained loads. Rail engineers who attended early demonstrations described the turbo response as a defining characteristic that distinguished the 251 from previous medium-speed diesels. The metallurgy behind the engine elevated its credibility even further. Alco invested in high-grade alloys for the cylinder liners, pistons, and connecting rods, creating a foundation of durability that held up under extended service conditions. Technical observers noted the strategic use of hardened surfaces and improved thermal resistance, which offered enhanced protection during temperature fluctuations in heavy-duty cycles. These decisions aligned with the company's long-term objective of delivering a prime mover capable of thriving in freight, passenger, marine, and industrial environments without frequent component degradation. Thermal efficiency emerged as another focal point. Reports from the period highlighted the 251's ability to achieve strong fuel utilization rates, which appealed directly to railroads seeking reduced operating costs across long divisions. Engineers examined combustion chamber geometry, injection timing, and airflow patterns, recognizing that Alco's refinements created an engine capable of extracting more useful energy from each gallon of fuel. The combination of improved airflow and precision injection strategies demonstrated a level of sophistication that captivated specialists who tracked efficiency metrics across competing engine platforms. The structural layout of the 251 contributed to its growing reputation. Alco implemented a modular design framework that simplified access to key components, enabling maintenance crews to service power assemblies, cylinder heads, and ancillary systems with greater efficiency. Shops that inspected the prototype appreciated the engine's practical serviceability, interpreting it as evidence that Alco intended to support long-term operational reliability rather than focusing solely on performance figures. The engine's arrangement suggested a deliberate attempt to balance engineering complexity with field-level practicality. Controversy grew as analysts debated how Alco achieved such a dramatic refinement within a highly competitive industrial environment. The technological leap raised questions among historians, some of whom argued that Alco pursued an uncommonly aggressive development cycle shielded from public scrutiny. Rumors circulated within trade circles claiming the company employed specialized testing protocols and private engineering teams that operated beyond standard corporate oversight. These discussions intensified because the 251 represented a leap that did not match the cautious pace typically associated with American locomotive development during the era. The arrival of the 251 placed Alco directly under the brightest spotlight the company had ever faced. Industry insiders observed the engine's capabilities with a mix of awe, skepticism, and curiosity, each group trying to determine whether Alco had engineered a breakthrough capable of shifting the balance of power. The design forced competitors to reconsider established assumptions and left railroads re-evaluating their long-term equipment strategies. The 251 emerged as a prime mover that shaped discussions far beyond its specifications, drawing attention to the deeper engineering philosophies that shaped its creation. The defining moment arrived when Alco invited railroad executives, senior engineers, and industry analysts to witness the 251 engine under controlled but demanding performance trials. These demonstrations were conducted with full transparency, using calibrated equipment and detailed measurement protocols that allowed observers to track horsepower, fuel flow, temperature stability, and turbo supercharger behavior in real time. The audience expected incremental improvements, yet the 251 delivered performance figures that exceeded conventional medium-speed diesel benchmarks. The reaction inside the test facility shifted instantly, the room filled with a restrained but unmistakable sense of surprise. Engineers watched the 251 sustain power output across extended high-load intervals with a consistency that drew immediate attention. The turbocharger responded fluidly to rapid load adjustments, creating a power curve that impressed mechanical officers who valued responsiveness in freight and passenger operations. Fuel burn patterns displayed smooth, predictable behavior, reflecting efficient combustion and refined airflow management. Temperature readings remained within precise tolerances, a detail that appealed to maintenance supervisors who understood the long-term implications of thermal discipline on engine longevity. The atmosphere around the demonstration grew increasingly charged as specialists compared their notes. Observers documented cylinder pressure trends, vibration signatures, and exhaust characteristics, each measurement reinforcing the sense that Alco had engineered a platform capable of challenging existing power plants across multiple applications. Some attendees later described the moment as an unexpected disruption of industry expectations. The 251 performed with a level of refinement that created discussions about new engineering thresholds for medium-speed diesels. Whispers circulated almost immediately after the test concluded. Analysts debated the methods Alco used during development, suggesting the company may have pursued an ambitious research timeline, supported by specialized test regimes. Speculation grew that Alco intentionally withheld detailed information about the 251 until the engine reached peak readiness, allowing the reveal to carry maximum strategic impact. These theories gained traction because the performance gap displayed during the trials suggested an intensity of preparation that observers rarely associated with traditional corporate pacing during the period. The demonstrations redefined how critics viewed Alco's engineering capabilities. Many who previously questioned the company's direction began reassessing their assumptions, citing the 251's stability, efficiency, and responsive power delivery as indicators of a deeper engineering resurgence. The event shifted industry conversations from skepticism to intrigue. Alco had presented an engine that commanded respect from technical experts and created pressure across the competitive landscape. The 1959 trials became a milestone that marked the moment Alco reasserted itself as a formidable contributor to the evolution of American diesel technology. The introduction of the Alco 251 immediately triggered comparisons with the dominant EMD 567, a power plant that had shaped American dieselization throughout the 1940s and 1950s. Railroads recognized the 567 as a dependable medium-speed workhorse, supported by a vast service infrastructure, yet the 251 presented capabilities that shifted long-standing assumptions. Engineers studying the 251 observed that its horsepower per cylinder output surpassed the figures associated with the 567, creating a performance profile that attracted attention from rail divisions looking for stronger pulling power on demanding routes. The turbo supercharging system contributed significantly to this advantage, producing robust high-altitude and high-load performance that appealed to railroads operating through mountain territory or heavy coal regions. The technical contrast between the two engines extended into fleet operation records. Maintenance data gathered during early field deployments highlighted the 251's reliable thermal behavior and durable component construction, which aligned with Alco's emphasis on improved metallurgy and refined combustion geometry. Shops that evaluated the engine concluded that the 251 delivered consistent operational performance across sustained cycles, reinforcing its credibility as a long-term investment. These findings created tension in the locomotive market because many railroads had invested substantially in EMD's established ecosystem. The emergence of a competing engine with higher output potential and strong efficiency metrics forced procurement departments to re-evaluate assumptions regarding future motive power strategies. The comparison with Fairbanks-Morse introduced an entirely different kind of debate. Fairbanks-Morse engines carried a reputation for bold engineering through their opposed piston design, a layout that delivered strong power density and a distinctive mechanical signature. The architecture attracted enthusiasts who valued innovative configurations, yet it required maintenance teams equipped with specialized knowledge. This shaped operational considerations, particularly in regions where training resources varied. The Alco 251 entered this conversation with a more conventional configuration, supported by advanced turbocharging, improved materials, and high efficiency, prompting discussions about practicality in everyday service environments. Mechanical officers examined the two philosophies carefully. Some praised the 251 for offering a balanced blend of accessibility, power, and durability without introducing complex service requirements. Others continued to champion Fairbanks-Morse for its unconventional performance characteristics, arguing that the opposed piston concept represented a sophisticated approach to thermodynamic efficiency. These opposing viewpoints created one of the most energetic technical debates of the era. Trade journals recorded intense discussions, conference panels revisited design philosophies, and suppliers monitored the shifting opinions among railroads seeking long-term reliability and operational simplicity. The rivalry among Alco, EMD, and Fairbanks-Morse brought the diesel industry into a new chapter of competition. The arrival of the 251 highlighted engineering disparities, challenged established loyalties, and encouraged deeper scrutiny of design methods across the sector. The result was a surge of controversy that influenced purchasing decisions, maintenance practices, and the broader trajectory of American locomotive development. The rise of the Alco 251 created an atmosphere of speculation that lingered across the rail industry for decades. The engine appeared during a period of intense competition, and its rapid refinements sparked conversations that blended technical curiosity with corporate intrigue. Many observers believe the 251 represented more than a new product line. It became a symbol of Alco's determination to challenge the established hierarchy. This perception fueled ongoing debates about how the company developed an engine with such precise engineering during a time of financial pressure, competitive rivalry, and shifting market expectations. One of the earliest controversies centered on the idea that Alco may have discovered critical breakthroughs before the engine's official release. Industry insiders suggested the company could have been refining advanced turbocharging techniques, fuel injection patterns, and metallurgical innovations long before 1959. Supporters of this theory argued that Alco might have pursued private experimentation away from public scrutiny to avoid premature judgment from analysts and competitors. The timing of the reveal intensified the speculation, especially because the 251 demonstrated performance traits that exceeded the incremental advancements typically seen in medium-speed diesels of the period. Another area of debate focused on the internal pressures surrounding the engine's rollout. Several historians propose that Alco leadership sought a decisive achievement to strengthen corporate standing and influence investor confidence. Trade publications from the era documented tension within the locomotive sector, with analysts closely monitoring Alco's strategic moves. The 251's swift arrival created questions about the company's development methods. Some observers believed Alco accelerated testing cycles through rigorous, high-intensity trials that took place behind closed doors. Rumors circulated about specialized engineering groups, confidential design teams, and experimental components that never appeared in official documentation. These claims added layers of intrigue that supported the belief that Alco's engineering division operated with unusual urgency. The impact of the 251 extended into the broader competitive landscape, sparking discussions about how the engine affected long-standing alliances between railroads and manufacturers. The strong performance of the 251 generated renewed interest from railroads that previously favored EMD or Fairbanks-Morse, creating ripples across procurement channels. Suppliers, distributors, and service networks monitored these shifts closely because changes in locomotive preferences influenced everything from spare part contracts to maintenance practices. The possibility of Alco gaining momentum in strategic markets created tension among rival manufacturers who had maintained comfortable positions for years. The Alco 251 secured a legacy that extended far beyond the years of the company that created it. After its debut, the engine became a cornerstone of global locomotive fleets, marine propulsion systems, and industrial power generation. Countries across Asia, Africa, Europe, and South America adopted the 251 through licensed production, rebuild programs, and modernization initiatives. The engine demonstrated consistent resilience under tropical heat, mountain grades, heavy freight pressure, and extended operational cycles. Conditions that tested every prime mover of its era. The continued use of the 251 in modernized form reinforced its reputation as one of the most durable medium-speed diesels ever engineered. The engine's survival became a source of controversy among historians who study the trajectory of American locomotive manufacturing. Some argued that the 251 represented the highest expression of Alco's engineering capabilities, a moment when the company displayed the potential to reshape the industry. They viewed the engine's long-term global success as evidence that Alco possessed the expertise required to compete at the highest level during a critical period of diesel evolution. This interpretation portrayed the 251 as an achievement that warranted broader recognition within the domestic market. Other analysts interpreted its legacy through a different lens. They suggested that the engine's enduring performance highlighted specific corporate decisions that altered Alco's position in ways few expected. These discussions focused on strategic alignments, manufacturing priorities, and procurement trends during the 1950s and 1960s. The 251 became a reference point in debates about how engineering excellence interacts with market forces, corporate structure, and industry alliances. Each perspective contributed to the engine's mystique and ensured ongoing academic and technical analysis. The Alco 251 demanded attention from engineers, executives, and historians. Its influence extended through decades of locomotive evolution, inspired technological refinements across multiple manufacturers, and established a benchmark that shaped conversations about medium-speed diesel performance worldwide. The engine outlived its origin company, outlasted several competitors, and continued operating long enough to become a legend in its own right, a mechanical achievement that carried the spirit of Alco far into the future.